All right, time for some more worked examples from our equations of ellipses assignment. Please be careful what number you're on. This is number 7, but on the back of the first page. So it's the first number 7. And this one, like the first sections, the first 1 through 12 is everything centered at 0, 0. And then after that, when it starts over at 1 again, things are not centered at 0, 0. So sorry, this one's a little bit before. You can skip this example if you don't need it. But if you need this one, here we go. So the way I can tell this is centered at 0, 0 is just get the halfway point between your vertices. You can also do the same with your foci. Your center is going to be halfway between negative 8, 0 and 8, 0, which is at 0, 0. And this also lets you know, using your center and one of your vertices, that distance, that's the A distance. So A is going to equal 8, which means A squared is going to equal 64. Well, you are also going to need your B squared. We don't currently have the minor axis length here, but you can use your foci to get C, and then you can use C to get B. I know it's kind of a mess, huh? And so you can figure out the distance from a focus to the center, and that's going to be C. So between 0, 0 and 5, 0 is 5. So C squared is going to equal 25. And now you have to remember your Pythagorean relation, which on your notes it's A squared is B squared plus C squared. We did solve that for C squared, making this, but we're not going to do that this time. We're going to start with this. A squared equals B squared plus C squared, because we have A and C, we're trying to find out B. And so we got, it's right over here, A squared equals B squared plus C squared, and we'll plug our numbers in. We got 64, B squared, and then 25. Let's subtract off the 25, and now we got B squared is 39. We don't need to get B to write our equation, but if you're going to graph it, you want to figure out your B value by square rooting. So now we have A, we have B, and we have our center. You can write out the equation of this ellipse, which is x minus h squared and y minus k squared, but h and k are 0, so we just got x squared, and we got y squared. And we're going to be adding, they're going to be over a squared and b squared, and it's going to equal 1. You do have to make sure you're checking which direction is the longer distance. Since these are horizontal from each other, this is a horizontal ellipse, which means a squared is going to go under the x. So you got 64. The b squared is going to go under the y, which is 39, and now you have your equation. Let's move on to another one. I know, you just love having all these wonderful examples. Again, if you feel like you got it, you can skip it or pause it, work through it, and then jump to the end and check it. I'm just trying to explain my thoughts and the process as I go through these for your benefit. This is not the next number 8. This is the second number 8 in your little packet there. So that's on the last page. So jump to the last page, number 8. So first things first, we need to figure out our center, figure out if it's vertical or horizontal, and then we can get our b squared and write our equation. So again, you can get your center just by finding the midpoint between two vertices or two foci. Halfway between 3 and 3 is 3. Halfway between negative 7 and 3 is going to be at negative 2. If you want to get that, you just do negative 7 plus 3 and divide by 2. You get negative 4 and divide by 2. You get 2. Okay, so you got your center. So you have your center. You can find your A value, which is how far is it between 3, negative 2 and 3, 3, or 3, negative 7. That comes out to be 5. And in doing that, you can see you're going between, on these, the y's is changing. So that's going to make this a vertical ellipse, not a horizontal one. A is going to be 5, which means a squared is 25. And we don't have the b. We can't get the b squared, but we can use our foci to get the c. So we use these 2 bits of information to find the c. So between 3, negative 2 and 3, negative 6 is just a matter of 4. So c is 4, which means c squared is 16. So now we can use our Pythagorean relation, which is a squared is b squared plus c squared, to find our b value. So let's plug in 25 and 16. And you can subtract your 16. And now we're looking at 9 is b squared. And you can do some square rooting to get that b is 9. So now, we actually don't need b. Sorry. And the square root of 9 is not 9. B squared is 9. That's the number we need. Sorry about that. So now we have our center, we have our a squared, we have our b squared. We can write out our equation is x minus the x value of our center, which is 3. So x minus 3 squared. And then we got plus, and then we got y minus the y value of our center, which is negative 2. So it's going to be y minus negative 2, which is y plus 2. There. And now we need to put a squared and b squared in there. It's going to equal 1. The a squared is the bigger value, and we already determined this is a vertical ellipse, so you can put 25 under y plus 2 squared. And then b squared, it goes under x, the x part, because it's a vertical ellipse, and now we have our equation. I got one more example for you, and this is number 11, the second to last one. I wanted to just kind of show you a little difference here. So this one, again, it gives you vertices, so you can get the halfway point between your vertices, and that'll be your center. So you find our center. Halfway between 0 and negative 6 is negative 3, and then halfway between 2 and 2 is 2. So we got our center at negative 3, 2. And we can also use this information to find our a value. So vertex to the center is the a distance. So between 0 and negative 3 is a distance of 3. So a squared is going to equal 9. So let's just figure out how far it is between those. And that's my a distance, and I'll square it to get 9. But now we need to get our b value. And our other bit of information we have is this. The length of the minor axis is 2. And if you're remembering your ellipse, actually let's figure out what kind this is. It looks like the x's are changing. That makes it a horizontal ellipse. The minor axis length is all the way across. So this is 2. And b is half of that, right? B is half the distance. So b is going to be, well, 1/2 of this 2 up here, which means b is 1. And since b is 1, b squared is also 1. So we have a squared, we have b squared, and we have our center. We can write our equation. You don't need to get your foci or your c distance on this because you already have a and b. So now we're going to write out x minus the x value of our center, which is negative 3. So x minus negative 3, which will give you x plus 3 squared. And then we got y minus the y value of our vertex, which is 2. Sorry about that. So we got y minus 2, because our k value is 2 squared. And it's going to equal 1. All these equations of ellipses equal 1. It's really convenient. So we already determined this is a horizontal ellipse, and so a squared is going to go under the x part, and b squared is going to go under the y part. Let's make this more 9-like, and voila, you have your equation. So hopefully that's helping out with your assignment. Again, ask questions on the Canvas course if you have them, and I'll try and help out the best I can. Good luck.